Sam Pruitt back here at J&L Laboratories in the Permian Basin, and I'm here to talk to you about testing paraffin inhibitors using a cold finger. And I've got Eric Trevino here to tell us all about it. Paraffinic oil is becoming a bigger and bigger problem for flow assurance, particularly in the Delaware Basin. We do a lot of testing of paraffin inhibitors utilizing this cold finger. So Eric's going to tell us a little bit about how all that works. Eric, thank you for taking the time to explain this to us.
Yep, so this is a test for paraffin inhibitors, not paraffin dispersants. So I always let customers know to not expect good results if they're testing paraffin dispersants on the cold finger. That's not what the cold finger is built to test. What we're trying to do is look at different paraffin inhibitors or wax crystal modifiers to see which of those are going to interact with the paraffin to ensure that there's as little paraffin adhering to the coupon. So what we're going to do is we're going to have to know certain characteristics about the oil. We'll know when the paraffin is going to start crystallizing. So with that information, we're going to set up the cold finger in a way that will cause the paraffin to precipitate out on the surface of the cold finger. What we'll be left with is the blank is going to be unprotected. There will not be any types of paraffin inhibitor inside there. So what we'll get is a nice coating of paraffin as our baseline. Then we'll look at the chemicals, and we're going to take the mass before and the mass after. We'll see which chemical provides the best protection percentage, and we'll include a picture in our report. So those chemicals that perform the best are going to have less paraffin compared to the blank. So preparing the instrument for the test is very simple. It's going to be software based. So what we'll do once we have our temperature parameters, we're going to set the temperature on the software at the rack, which is going to refer to the box here. So we'll have our oil at a temperature. We'll have our fingers at the temperature that we're going to cause the paraffin to precipitate out at. So once we have those temperatures decided, we'll program them into the software, press start, and we're going to have our oil heated up well above the cloud point to make sure that all the paraffin's melted, distributed evenly throughout. And to start the test, we'll start with our blank, and we'll pour out our volume into our beaker, and we'll put that onto our unit. We'll do the same thing for all of our chemicals. We're stirring the whole time to keep that paraffin distributed from top to bottom in the beaker. It's going to be at 160 degrees, so all the paraffin is going to be in the oil. And once we allow the temperature to stabilize inside the unit, we're going to drop our fingers into position, and we'll come back and check on it in a few hours, see how the paraffin is adhering to the surface of the blank. And we want the blank to have a nice coating of paraffin. If the oil does not have enough paraffin inside, then we may need to supplement it with some paraffin from the same system. So there are some cases where our default temperature settings are not working. They're not giving a good paraffin separation from products to the blank. So instead of just reporting it out and saying none of your chemicals worked, we go put forth the extra effort and evaluate different temperature parameters. Because the cold finger it's a finicky procedure, and unless you've done it quite a bit of times and you can see what's happening on the fingers, you'll know that either you don't have enough paraffin in the oil, or maybe you can't use your standard temperature separations. So instead of sending that report out, we treat this lab as if it were our own, associated with a chemical company. We came from the chemical side, so we know that we want the chemicals to work. And if it's not working under the standard test conditions, this cold finger is unique in that you may have the wrong temperature at the oil and the wrong temperature at the finger. So we will try to find the sweet spot so that our customers have the best chance possible at making a great recommendation.
Eric, thank you for taking the time to explain the cold finger and how we test paraffin inhibitors.
Not dispersants. Please don't send me a dispersant.
Sorry, that's my fault.
Off my game. Just off my game. It's the finger. And it gets cold. Everything that was annoying about cold fingers that we've built at previous places has been solved by the Germans, and with enough money, they're willing to give their ingenuity to you. The German sense of humor is a little bit different than the American sense of humor. Like anything in science in particular, because it's from Germany, you can make a homemade unit for maybe $15,000. So you could add an extra zero onto that, and this is what you would get here. But with the homemade units, you're real limited on your bottle positions. Most homemade units might have 6 bottles. These have 5 per unit, so it's like we have 3 cold finger units in one. So each rack can have its own temperature settings. So we could run 3 different oils if the customer's only wanting to look at 4 different dosage rates or chemistries. We could load up 3 different oils in here and run them independent of each other. With traditional cold finger units, you're backfilling the inside of the finger. So you have a tube going inside, and then you have another tube positioned above that. So you're filling it up with your coolant, and it's making its way back to the chiller. So whenever you pull this off, you're left with a whole bunch of coolant that's going to splash all over you, get your shoes dirty, get the floor dirty, leaves you with a big mess. But with these, it's a closed system. So once the coolant hits the end of the coupon, it'll return back to the chiller. So it never leaves the system. Another great thing is stability at the positions. They guarantee that it's accurate to within 2 degrees from rack to rack, and from bottle to bottle about 1 degree Fahrenheit. So with home built units, there's no way you can guarantee that. You have a chiller, you put a manifold on it, and you just hope that the flow is what you expect it to be, and it's not. I've seen several home built units, I made a couple myself. You cannot guarantee that your temperature positions are going to be within 1 degree across all of your cells. So they guarantee it, and we get very consistent results. The lines are insulated from the chiller up to this point. And there is another great feature that home built units don't have, and that's a temperature readback at the finger position. So this is position number 4. They call it the master position because there's a temperature probe that's soldered onto the outside of this finger. So not only is the chiller reading the temperature internally, it's also getting feedback from that temperature sensor at position number 4. This is definitely superior to anything that I could do and most other people in the world can do. And there is a reason that this is what all the labs who've ever ran cold fingers, this is the unit that they want, is a PSL cold finger.